Welcome back to Cosmic Compass. Today, let's embark on a journey to Saturn, not to see it, but to hear it. For centuries, space has been thought of as silent, a vast emptiness where no sound can travel. But Cassini, one of the most ambitious spacecraft ever launched, proved otherwise. Equipped with instruments designed to detect radio and plasma waves, Cassini spent over a decade listening to Saturn, its rings, and its moons. What it brought back was not just science, it was a symphony of the cosmos. Strange tones, bursts of energy, and whispers from alien worlds, all transformed into sounds we can experience here on Earth. So what does Saturn actually sound like? And what can those sounds teach us about the hidden forces shaping our solar system? Let's find out. Did you ever imagine that space is completely silent? It's a common idea, and for ordinary sound waves that travel through air, it's true. In the vacuum of space, there is no air to carry vibrations. But what if we told you that Saturn, the giant world with its rings and mysterious moons, is far from silent? Let's imagine ourselves orbiting around Saturn, not listening with human ears, but with instruments that can detect radio and plasma waves. Suddenly, the planet begins to speak. This isn't science fiction, it's real. For 15 years, the Cassini spacecraft circled Saturn, equipped with a radio and plasma wave science instrument capable of capturing the strange electromagnetic music of the planet and its moons. The result is eerie, almost haunting. 30 minutes of data compressed into a single minute of sound reveal bursts, whistles and tones. And yet, these recordings were not made for theatrics. They carried a genuine scientific purpose to help us understand what kind of processes were happening around Saturn. So what exactly was Cassini hearing out there? Let's begin with one of Saturn's most spectacular natural wonders, the aurora. The sun constantly blasts out streams of charged particles known as the solar wind. When these particles encounter a planet with a strong magnetic field like Saturn, they are funneled toward the poles where they collide with the upper atmosphere. This creates aurorae, dazzling lights we can see on Earth near the poles, but on Saturn they are even more powerful. These collisions excite atoms in the atmosphere, causing them to emit electromagnetic radiation. Some of it we can see with our eyes as glowing arcs of light, but aurorae also emit radio waves invisible to us, yet perfectly detectable by Cassini's instruments. Picture these radio waves bouncing back and forth inside Saturn's immense magnetic field, trapped like echoes in a giant chamber. Cassini drifted through this invisible arena, recording the planet's natural broadcast. What we hear from those recordings is Saturn's aurora singing in radio frequencies. It's a reminder that what looks like a serene distant giant from afar is in reality alive with invisible storms and energies. If you thought Saturn was just a quiet frozen world, the aurora alone proves that appearances can be misleading. Now, how do we know that Saturn's magnetosphere really traps and shapes these waves? Cassini provided a direct answer when it crossed into and out of this region. Imagine being outside Saturn's protective bubble, drifting through the solar wind. Everything is calm, radio waves are minimal, and the silence seems absolute. But as Cassini moved closer, it encountered a sharp boundary, the bow shock. The bow shock is where the solar wind collides head-on with Saturn's magnetic field. At that moment, the spacecraft was hit with a sudden storm of radioactivity. The calm dissolved into bursts and pulses as though the planet had flipped a switch. Once inside the magnetosphere, Cassini heard a constant hum of energetic activity, completely different from the quiet outside. For us, it's like stepping from a silent corridor into a crowded, echoing hall. The transition is abrupt, unmistakable. Saturn's magnetic field wasn't just theoretical, it was a living active shield that Cassini could quite literally hear. But Saturn had more to offer than aurorae and magnetic boundaries. Cassini also tuned into the giant planet itself, and what it discovered was staggering. Saturn is wrapped in a thick, dynamic atmosphere, where colossal storms rage across its cloud tops. These storms produce lightning, not just any lightning, but bolts thousands of times more powerful than what we experience on Earth. Cassini's instruments recorded the radio emissions from these lightning strikes. At first, the sounds might seem small like faint crackles, but let's not be fooled. If a bolt of lightning on Earth can illuminate a city, then a strike on Saturn could unleash energy enough to be detected from orbit across the emptiness of space. It's a humbling thought. Storms so vast, so powerful, that their voices reached Cassini hundreds of thousands of kilometers away. If Saturn could be described as a living world, then these lightning storms were its thunderous heartbeat. Of course, one of Cassini's most daring tasks was to venture through Saturn's rings. This was not a gentle journey. Cassini was travelling at nearly 121,000 kilometres per hour, and the rings, though delicate from afar, are filled with icy particles. When Cassini crossed the faint Janus Epimetheus ring, its instruments picked up countless impacts. Each collision vaporized into tiny clouds of plasma, producing sharp, distinct bursts that we can hear as pops and crackles. The denser the ring, the more frequent the impacts. It sounded almost like static, but this static was caused by real dust grains smashing into the spacecraft at unimaginable speeds. Later in the mission, Cassini tried something bolder, flying through the narrow gap between Saturn and its innermost D-ring. At first, the instruments reported surprisingly little activity. Scientists wondered if the region was nearly empty. But further passes revealed the truth. The first time the particles were simply too small for Cassini's radio and plasma wave science instrument to detect. Another instrument, the Cosmic Dust Analyzer, later confirmed their presence. On subsequent orbits, Cassini detected a rising series of tones, strange signals that puzzled scientists. Were they natural plasma waves or something else entirely? To this day, their exact origin remains uncertain. For us, these passages through the rings are thrilling, not just for their science, but for the sheer daring involved. Imagine being inside that spacecraft listening as grains of dust explode into plasma all around you while racing through Saturn's rings at supersonic speeds. The data Cassini returned was more than numbers. It was a soundscape of exploration, danger, and discovery. If Saturn itself could speak through plasma and lightning, one of its moons whispered a different story. Enceladus, the small icy world with geysers erupting from its south pole, revealed a plasma connection to Saturn, much like Jupiter shares with its volcanic moon Io. Cassini detected a circuit, an electric current of plasma particles linking the moon to its giant parent. This was unexpected. Enceladus seemed too small, too fragile, and yet its activity influenced the entire magnetosphere. Using its magnetometer, Cassini measured how Saturn's magnetic field bent and twisted around the moon. This revealed that Enceladus had a thin atmosphere produced by jets of water vapor and ice crystals blasting into space from beneath its surface. These discoveries transformed Enceladus from a frozen moon into a world of extraordinary interest. It wasn't just a silent ice ball, it was active, alive in its own way, shaping Saturn's magnetic environment. Some even wonder if its hidden ocean could harbour the chemistry for life. In listening to Enceladus, we weren't just hearing a moon, we were eavesdropping on a dynamic system between a planet and one of its most intriguing companions. Among Saturn's moons, none captivated us more than Titan. Cassini's mission included one of the boldest experiments in planetary exploration, delivering the Huygens probe to Titan's surface. As Huygens descended through the thick orange atmosphere, it carried instruments to measure the world below. It used radar to determine altitude, sending back echoes that revealed its fall toward the unknown. These signals were our guide proof that the probe was approaching solid ground. But the most extraordinary moment came from a simple microphone. For the first time in history, humanity heard the atmosphere of another world directly. At first, the recording sounds ordinary, just a low rush of wind. But then it dawns on us, this is not Earth. This is Titan more than 1 billion kilometers away. What you are hearing is exactly what you would have heard if you had been sitting on Huygens as it plunged through the haze. It's an almost overwhelming thought. We often see pictures of distant planets, sometimes even videos made from spacecraft imagery. But sound, real sound, connects us to a place in a way nothing else can. The vacuum of space had finally given way to the breath of another world, and for a few minutes, Titan felt close enough to touch. For many scientists and enthusiasts, this recording was the most awe-inspiring of Cassini's entire mission. Not data points or graphs, but the direct voice of an alien world. In the end, Cassini gave us more than images and measurements. It gave us the chance to hear Saturn. From the eerie songs of aurora to the thunder of its storms, from the crackle of its rings to the whispers of Enceladus, and finally to the living breath of Titan's atmosphere, these sounds remind us that the universe is not silent. It is full of voices waiting for us to listen. If Saturn and its moons could tell such stories, what might the other planets or even more distant worlds be saying? Right now, we are explorers tuning into the cosmos, one frequency at a time. And as Cassini taught us, sometimes the most profound discoveries are not just what we see, but what we hear. And there we have it, the voices of Saturn and its moons captured by Cassini and Huygens. From the magnetic storms of the planet to the geysers of Enceladus and finally the winds of Titan, these sounds are more than recordings. They are windows into distant worlds, carrying us beyond the limits of our senses. As we continue to explore the solar system, one thing becomes clear: the universe is not silent. Every planet, every moon, has its own story to tell if we only know how to listen. If you enjoyed this journey, don't forget to subscribe to Cosmic Compass so you won't miss our next exploration into the mysteries of space. Together, let's keep asking questions, discovering new worlds, and listening to the cosmos.